Now let's start this chapter off with basic table of trigonometric ratios. Now, basically, what this means is that mathematics have constructed tables given the values of the trigonometric ratios of large number of angles between 0 and 90 degrees, and these are called the tables of natural sines, cosines, and tangents. So these are the basic trigonometric functions we deal with, and we can construct the other ones by using them. Technically, you can construct the table of a tan function as well from both the sine theta and the cos theta. So basically, technically speaking, the sine theta and cos theta tables are the most important ones because the others build off of them. Now, the reason we have three is because these are angles of triangles, basically, right? That's why they're between 0 and 90 degrees. So basically, if you have, let's say, this triangle over here, right? A right angle triangle, and say this is theta. Now, let's say that theta is 0 degrees, and you know that sine theta is basically, let's define these sides. This is the opposite side, this is the hypotenuse, and this is the adjacent side. Okay, so sine theta is basically this angle. If you have to take the sine of this angle, it has to be opposite over hypotenuse, right? So if the angle is 0, obviously there will be no opposite side, which is why sine theta is 0. On the other hand, cos theta is 1, because if this angle is 0 degrees, means this entire thing is closed down. That means that the adjacent side is equal to the hypotenuse, right? They will intersect. So cos theta will be 1, and tan theta is just is basically the adjacent over the opposite over the adjacent. And since the opposite side is gone when the theta is 0, that means that tan theta will be equal to 0. Now, sine 30. Let's talk about sine 45 first. Sine 45 means that you have basically a equilateral triangle. So basically, say that this is your 90-degree angle, then these other two sides must be equal in length, right? So this will be 45. If this side is 45, this side will also be equal to 45 degrees, because the total angle inside the triangle must eventually equal to 180 degrees. So we already know that 90 plus 45 plus, we know the two angles, 90 and 45. So the third angle must be 45 for all of this to equal 108 degrees. So this is an equilateral triangle since two angles are the same. And the adjacent in this case will equal the opposite side, right? Because the angles are equal. So this side and this side are equal. And so you're just left with the hypotenuse. And let's say that these sides are, if the adjacent is 1, right? Yeah, so if the adjacent is 1 and the opposite is also 1, the hypotenuse can be found by the Pythagoras theorem, which states that the adjacent square plus the opposite square must equal the hypotenuse, right? So the hypotenuse square, sorry. So the hypotenuse is basically equal to 1 plus 1 under root. So under root 1, right? So yeah, so under root 2, because it's 1 plus 1. So 2 and under root 2. And yeah, so basically this would give you, since it's the opposite over the hypotenuse, that would be 1 over under root 2, and that's exactly what you have here. So all of these values that you see over here, they can be found by the basic triangle, right? And just to make life easier for yourself, if you're given the values of sine theta and cos theta, you can find tan theta by just taking sine theta over cos theta, right? You already know this. Tan theta is equal to sine theta over cos theta, which is why in case of 90 degrees, sine theta is 1, but cos theta is 0, which means that this cos theta in the denominator will become 0, and hence tan theta will become undefined. right? So yeah, this is just the table. It's easy to derive all of this, but again, if you want to memorize it, that's how you benefit as well. Now, let's see how you can solve a right angle, right angle triangle, or the right triangle. So basically, you have to find the three sides and the three angles of the triangle. And let's see how you can find those given a limited amount of information. So basically, in order to solve a right angle triangle, you need to have two things. We have to find these two things. You have to find the two acute angles and the length of the three sides, right? As again, like I said, the three sides and the three angles. But again, in one of these angles, one of these angles is 90 degrees in a right angle triangle. That's why it's called a right angle triangle. So technically speaking, you already have one angle given to you, the 90 degrees, and you need to find the two other acute angles and the three sides. Okay. Now, we know the trigonometric ratio of an acute angle of the right angle of a right angle triangle involves three quantities, right? The lengths of two sides and the measure of an angle, right? So if you have the lengths of two sides and one angle, you can find the other quantities as well, right? So let's see an example. So you have this triangle over here. You already know this 90-degree angle. You know this 45-degree acute angle. So obviously, again, you can find the other angle over here, since the total of all three angles is 180 degrees. And then you're also given one of these sides. This side is 4, so you can find the other two sides by applying the trigonometric ratios, right? So since A is 45 degrees, this angle, again, in a triangle, we'll denote the three sides with A, B, and C. So the angle with A will denote as alpha, the angle with B will denote as beta, and the angle with C will denote with gamma, right? So that's just to make your life a bit easier. So alpha is 45 degrees. So beta is 90 degrees. In this case, we're giving beta 90 degrees. So this one is gamma, right? This one is beta. And obviously, the total of the angles inside a triangle is alpha plus beta plus gamma. And that equals 180 degrees because that's the total of an angle inside a triangle. So you can find gamma by simply inserting the values. Alpha is 45, beta is 90. So obviously the angle at B, gamma, will be 180 minus 45 plus 90, which is 45 degrees. So it's an equilateral triangle, right? So now you can find, basically, again, if you draw the triangle over here, let's say that this was the triangle, a rough sketch. This was 45 degrees. This is also 45 degrees. This is 90 degrees. And we know that this side is 4. So we need to find the other two sides. Sine 45. This is alpha. This is side A. This is side B. This is side C. So BC is 4. So sine 45, right? Sine 45, the sine of this angle, is the opposite over the hypotenuse, right? So BC over AB. Now, we know that BC is 4. We need to find AB. So now, whoops, sorry. Let me just rub that off. So 4 over AB. Now we know from the table that sine 45 is 1 over under root 2, right? You can refer to the table back. And now you can find AB, which is equal to 4 into under root 2, right? Just cross multiply AB over here, under root 2 into 4. Now we know that now AB is 4 over under root 2. Now let's find this side, AC. So the cos of this 45-degree angle is the adjacent, which is AC, over the hypotenuse, which is AB. So you can just replace those values, and eventually that gives you AC is equal to 4, right? So now AC is 4. So now you have all of the requirements that you need. You have the three angles, 45, 45 and 90 degrees. You have the three sides, 4, 4 and 4 into under root 2. Also, you can make your life a little bit easier over here. Since this is an equilateral triangle, because this angle and this angle are both equal, that means since BC is 4, AC is also 4. And then you can just apply the Pythagoras theorem or anything, or a trigonometric ratio to find the hypotenuse. Now let's find the unknown angles and sides by using two sides that are given to us. So we saw a question earlier, right? And in it we actually had an angle and a side given to us, so we could find all of the other requirements, all of the other sides and all of the other angles using those, right? Or remember that we're dealing with right angle triangles, so there is always one angle of 90 degrees that is always there. So we talk about all the other things that are available to us. So you have these. You need to find this angle, you need to find this angle, and you need to find this side, right? So let's see. Now I think I've denoted these a little bit wrong, so let me just make it a bit clearer for you. We know that alpha is 90 degrees, right? And beta is the angle at B, and gamma is the angle at C, right? So this is beta and this is gamma. So we know that cos beta, the cos of this angle beta, is the adjacent over the hypotenuse, so 5 over 10. So you can, since 5 is AB, so AB over BC. We know AB is 5 and you know BC is 10, so you can find beta by taking cos inverse of AB over BC. So 5 over 10, cos inverse of 5 over 10, so cos inverse of 1 by 2, and that gives you 60 degrees. So now you know that beta is 60 degrees. Now you know that sine of the same angle beta is the opposite over the hypotenuse, right? So we already know that the hypotenuse is 10 and the opposite is AC, right? And just to make it very clear how that happens, this is basically, this was B, this was C, and this was A, right? This was 90 degrees. We found out this angle is 60, and we know that this is 10, and this was given to us as, I believe, 5. Yeah, AB was 5, so AC is unknown. So you can find AC by taking the sine of the 60-degree angle, so that would become AC over BC, and that would be AC over 10. So now you can just do the cross multiplications. We know that sine 60 from the table is under root 3 over 2, and so now AC is equal to 10 into under root 3 over 2, which is 8.66. So now you have this as 8.66. So all you're left with is to find this angle gamma, right? And that is very easy to do, because you know that the total sum of the angles inside a triangle is 180 degrees. We already know the two angles are 60 and 90. So simply you subtract the two angles you know from 180 to get gamma, which gives you 30 degrees. So now you have all of the information required and you've solved the right angle triangle. Now let's see how you can find the angle of elevation. So basically it says, this is a question that explains what the angle of elevation is. I think it's very self-explanatory, but just in case, it says that the vertical pole 8 meters high and the length of its shadow is 6 meters. What is the angle of elevation of the sun at that moment? So basically what that means is, if you have this pole, by the way, always draw diagrams, that makes things a lot easier for you. This is an 8-meter pole, right? Sorry, an 8-meter pole, and the sun is casting its shadow at 6 meters. What is the angle of elevation of the sun? Well, just complete this triangle, right? And this will be your angle of elevation. Simple, right? Because again, the elevation of the sun, wherever it is, is at this angle, which makes this the shadow of this pole at 6 meters, right? Because if you extend this line, this hypotenuse, it eventually reaches the sun, and hence this is the angle of elevation from the ground. So now you have to find this angle, and now it's very simple, right? Again, this is the same diagram. You have to find this angle alpha. And simply, since you're given the opposite and you have been given the adjacent, you can use these two by taking the tangent of alpha. The tangent of alpha is the opposite over the adjacent. The opposite is BC and the adjacent is AB. So now you just take the tan inverse of 8 by 6 or 4 by 3 and you get the angle of elevation alpha, which in this case is 53 degrees and 8 minutes, which is basically just 53.8 divided by 60, right? Because 1 degree is basically 60 minutes, so 1 minute is 1 by 60th of a degree, right? So you can just find that out. 53 point whatever 8 by 60 is, right? So 8 by 60 is just 2 into 4 and 2 into 30, 4 over 30, do that again. So that's 2 over 15, right? So 2 over 15, 53 point whatever 2 over 15 gives you. So yeah. Now let's see how you can find the height using the angle of depression. Now basically, it says that a plane flying directly above a post 600 meters away from an anti-aircraft observe the gun at an angle of depression of 27 degrees. Find the height of the plane. So basically, this is the diagram. It says that a plane flying directly above a post 600 meters away from the anti-aircraft. So, and it observes the gun at an angle of depression of 27 degrees. So, this is the aircraft, okay? And it observes the anti-aircraft gun at an angle of depression of 27 degrees. So the depression is 27 degrees below the angle at which the aircraft is moving, which is this over here, right? So 27 degrees below this line, and go on, let's say the gun is over here at A, which is exactly 6,000 meters from the point that is directly below the gun and below the aircraft. So the point directly below the aircraft at C is B, and 6,000 meters ahead of that at A is the gun, right? And the angle that the angle of depression that the aircraft makes from the gun is 27 degrees. And that is equivalent to saying that the angle of elevation that the gun makes from the angle of elevation that the gun makes to look directly at the aircraft is also 27 degrees. These are opposite angles. Not opposite angles, I think they're called alternate angles, right? But they're equal. The angle of depression over here is equal to the angle of elevation over here. Okay? And let's say that the height of the plane is x, right? So this is the height of the plane from the ground. And that is what we have to find, the height of the plane. So we know that tan theta is equal to perpendicular over the base, or which is also called the adjacent. Now, the angle of depression is 27, so we can find out that the angle of elevation from A is also 27 degrees. Now, the tangent of 27 is basically x over 6,000 because it's perpendicular over the adjacent, or the opposite over the adjacent, right? The perpendicular is also called the opposite. So now, basically, it's x over 6,000 and theta is 27, right? So now you can find x by simply solving this, and that gives you tan 27 into 6,000, which is equal to 3,057.15 meters, and that is the height of the aircraft from the ground. Now let's see how you can solve a triangle by using the law of sines. Now, so far we've used trigonometric ratios, right? And we've used the hypotenuse rule, and we've used the fact that the total sum of angles inside a triangle is 180 degrees. Now we'll see the law of sines. The law of sines basically states that if you have this triangle over here, right? And it says that this angle, let's say alpha, this angle beta, let me just draw it a little bit bigger for you to understand it, right? It basically says you use the law of sines when you do not have a right angle triangle, okay? So if you have this triangle over here, right? Say this angle is alpha, and this side is A. This angle is beta, let's say this side is B, and let's say this angle is gamma, and this side is C. It says that the opposite side of angle alpha, let's say it's side lowercase a, the opposite of this angle gamma is this side, right? Let's say it's lowercase c. The side that is opposite to this angle beta is this side, right? Let's say this is lowercase b. The law of sines says that side a over sine alpha is equal to side b over sine beta, which is equal to side c over sine gamma. This is the law of sines. Now let's see how you can solve a question by using this. Okay, just remember this. So basically now you're given that the side A is 53, and you're given that the angle beta is 88 degrees and 36 minutes, which basically means just 88 36 by 60 in mixed fractions, right? So it's 88 point something, and the angle gamma is 31 degrees and 54 minutes, which is just basically 3154 by 60, which is like 31.8 something or 9 something, I don't know. So alpha is obviously equal to 180 minus beta minus gamma, right? Because alpha plus beta plus gamma equals 180 degrees. So alpha is 59 degrees and 30 minutes, which is just 59 30 over 60, which is 59.5, by the way. 59.5 degrees. Now that you have all three angles, you need to find the side B and the side C and the side C, right? Because again, this is not a right angle triangle, so you cannot use the sine ratios, the trigonometric ratios as we did before. You'll use the sine rules, the law of sines. So side A over sine alpha is equal to B over sine beta, right? As I've seen over here. So side B is equal to A into sine beta over sine alpha. Now side A is 53 and beta is 88 degrees and 36 minutes, and alpha we found out is 59 degrees and 30 minutes. So now you can find the side B. So side B has a length of 61.49. Now let's find side C using the same method. So C over sine gamma is equal to B over sine beta. So C is equal to B into sine gamma over sine beta. And we already know what B is. It's 61.5. We found that out earlier. We know that gamma was equal to 31 degrees and 54 minutes. And we know that beta is equal to 88 degrees and 36 minutes. So now simply do all the multiplications and you can find out that the side C is equal to 32.51. And so now you have all of the requirements. You have sides A, sides B, and side C. And you also have angle alpha, beta, and gamma. So you've solved the triangle by using the law of sines. Now let's solve a triangle using the cosine formula. Now, Just like the law of sines, you can use this to solve a triangle that is not a right angle triangle. So let's say you have this triangle over here, right? And say that this angle is angle alpha. Now the side opposite to angle alpha, let's say that is A. This is angle beta. The side opposite to this angle beta is this side B. This is angle gamma. The side opposite to this angle gamma is side C. Now, the formula states that if you have to find out the angle alpha, you write down cosine alpha. That will be equal to, first of all, the sum of the sides that make up the angle alpha. So the angle alpha is made up by the side C and the side B. So B square plus C square minus the side that is opposite to this angle alpha, which is side A, right? Minus A square divided by 2 into the sides that again make up the angle alpha, which are C and B. 2BC. This is just 1. So now, for example, if you had to find cosine of beta, you would use the same logic. First of all, the sum of the sides that make up the side B, the angle B, beta, which are C and A. So A square plus C square minus the side that is opposite to the angle beta, which is B, so B square, over 2 into AC, right? So now let's see. By the way, if you rearrange this first one over here, right? If you rearrange it, it gives you A square is equal to B square plus C square minus 2BC cosine of alpha, right? And this will be relevant because let's see how you can do this question. You have been given that the side B is 95 and the side C is 34 and the angle alpha is 52. Now let's see how you'll find out the side A, the angle beta, and the angle gamma, because those are the only things remaining to solve the triangle. Now, using the cosine formula, which is this one, using the angle alpha, because that's the one given to us, you can find out the value of the side A, which we have to find. So, you know that B is 95, C is 34, and you know that the angle alpha is 52. So now, just replace the values. A square is equal to this. Take the under root of this value to get the side A, and that gives you 78.7644. Now that you have the side A, you would basically have all three sides, A, B, C, and you also have the angle alpha. So now using this law of sines, you can find out the angle beta and gamma as well. So now, A over sine A is equal to B over sine beta. A over sine alpha is equal to B over sine beta. So now you can use this to find out the value of this angle beta. So beta turns out to be, sine beta turns out to be 0.9505. Take the sine inverse of this to get the angle beta, which is 71 degrees and 53 minutes, which is basically just 71, 53 over 60 in improper fractions. And yeah, let's use this. Instead of using the law of sine, you can just use the logic that the sum of all the angles in a triangle equals 180. So gamma is equal to 180 minus alpha plus beta, right? Which just gives you 56 degrees and 7 minutes, or 56, 7 over 60. So now you have everything you need to solve the triangle. Now let's see how you can solve a triangle by using the law of tangents and the law of sines. We already discussed the law of sines before, so let's discuss the law of tangents. Again, it's the same as the law of sines and the cosine formula. You can use it to solve triangles that are not right angle triangles, because otherwise you can just simply solve it by using the trigonometric ratios. So let's say you have this triangle over here. This is angle alpha, so the opposite side is A, angle beta, the opposite side is B, the angle gamma, and the opposite side is C. Now, the law of tangent says that, for example, if you had B minus C over B plus C, that would be equal. to tangent of the angle opposite to B, which is beta, minus the angle, because since this is minus, right, this is minus, you'll have a minus over here as well, minus the angle opposite to C, which is gamma, over 2. And you'll do the same for the denominator, so tangent of beta plus, because it's plus over here, plus gamma over 2, right? You can use the same logic for, say, a minus b. So a minus b is equal to a plus b, which is equal to tangent of the angle opposite to a is alpha, minus, because it's minus over here, minus beta over 2 over tangent of alpha plus beta over 2, right? So this is the tangent rule. And let's see a question. It says that the side B is 61, the side C is 32, and the angle alpha is 59 degrees and 30 minutes, right? Or 59.5 degrees. So beta plus gamma is equal to 180 minus alpha. Obviously, we need this beta plus gamma, so you can use this formula over here. And alpha, so yeah, basically beta plus gamma is equal to 120 degrees and 30 minutes. But we need beta plus gamma over 2. So you just divide this by 2, and you get 60 degrees and 15 minutes. Now using the law of tangents, which is this formula over here, right? The same formula used over here. Now, you've been given beta plus gamma over 2, right? Which is this value over here. So now you can find out beta minus gamma over 2. So you can just cross multiply it over here. So tan beta minus gamma over 2 is equal to b minus c over b plus c into tan beta plus gamma over 2, right? Basically just multiply this on the left hand side. So you get this, right? So tan beta minus gamma over 2 is equal to 0.5456. So take the tan inverse of this and you get 28 degrees and 36 minutes. Cut this out, by the way. So yeah, beta minus gamma over 2 is equal to 28 degrees and 36 minutes. Now, beta minus gamma is equal to 2 times beta minus gamma over 2. So you get 57 degrees and 12 minutes, right? So you add up basically beta plus gamma and beta minus gamma, which gives you beta plus gamma minus gamma. So you can cut them out. So this is equal to 2 beta. So you were given the value of beta plus gamma before. I guess it was something like 120. Yeah. Let me just rub this off, just for clarity's sake, right? So beta plus gamma was equal to 120 degrees and 30 minutes, right? So beta plus gamma plus beta minus gamma is equal to 2 beta, which is equal to 120 degrees and 30 minutes plus 57 degrees and 12 minutes, which is 177 degrees and 42 minutes. So beta is equal to just 177 degrees and 42 minutes divided by 2, which is 88 degrees and 51 minutes. Now that you have the angle beta, you now subtract these same two equations, right? So that gives you basically beta plus gamma minus beta minus gamma gives you 2 gamma. So 2 gamma is equal to beta plus gamma, 120 degrees and 30 seconds, minus beta minus gamma, 57 degrees and 12 minutes, which gives you 63 degrees and 18 minutes. So divide this by 2 and you get 31 degrees and 39 minutes. So gamma is equal to this. So now you have alpha and beta and gamma. Now you can use the law of sines to find the sides. So A over sine alpha is equal to B over sine beta. Let me just rub all of this off. And So A over sine alpha is equal to B over sine beta, which gives you A is equal to B sine alpha sine beta, because we knew B from the start, it was 61, and now you can find out the value of A, which turns out to be 53. Now let's solve a triangle by using the half angle formula. So if you have three sides given to you and no angles, well, you can use the half angle formula for it. So here's the thing. The first thing you need to do whenever you're using the half angle formula is to find S. What is S? You just add up the three sides and divide them by 2, and that's S. Very simple so far. In this particular case, it's 11.5, right? By the way, by looking at this, you can see that it's an equilateral triangle, because it's not an equilateral triangle, it's an isosceles triangle, because it has two equal sides, right? And two equal sides mean two equal angles as well. So let's see. It says that S minus A is equal to 11.5 minus 7, obviously because A is 7. So that gives you 4.5. So you have S minus A. S minus B is also 4.5 because B is also equal to 7. S minus C is 11.5 minus 9, so 2.5. So now you have these three values, S minus A, S minus B, and S minus C. Now, tangent of alpha by 2 is equal to S minus B over S minus C over S into S minus A. This is just a half angle formula you'll have to memorize, right? There is a derivation for it, but we'll not get into that right now. Tangent of alpha by 2 is equal to S minus B into S minus C over S into S minus A whole under root, right? So alpha is basically the angle that is opposite to A and between the sides B and C, right? So you replace those values, you already found out all of these values, and basically you get this 0.4663. Now take the tangent inverse of this to get alpha by 2, which is 25 degrees, right? And alpha is obviously equal to 2 into 25, so 50 degrees. Now tangent beta by 2 is equal to S minus C over S minus A over, S minus C into S minus A over S into S minus B whole under root. Now you can see a pattern between tangent of alpha by 2 and tangent of beta by 2, right? What's that? Well, tangent of alpha by 2 was equal to under root S minus C into S minus B over S into S minus A, right? Now the thing is, in the numerator, you basically subtract S from, you subtract the two sides that make up the angle itself from S and multiply the results and divide that by S into S minus the angle that is opposite, the side that is opposite to the angle, right? So for example, if you have this triangle over here, right? This is the angle alpha, this is the angle beta, this is the angle gamma, right? So the angle opposite to the side opposite to angle alpha is A, the side opposite to beta is B, the side opposite to gamma is C. Now tan alpha by 2 is equal to S minus the first side that makes up the angle beta, which is C, into S minus the second side that makes up the angle alpha, right? So C, and the second side is B. So S minus C into S minus B over S into S minus the side that is opposite to the angle alpha, which is A, right? Similarly for beta by 2, under root S minus the first side that makes up beta is C into S minus the second side that makes up the angle beta, which is A. So S minus C into S minus A over S into S minus the side that is opposite to the angle beta, which is B, right? So this is the relation so far. And so in this case, tangent of beta by 2 is 0.4663. And hence, let me just rub this off, right? In this case, again, beta by 2 is 25 degrees. And so beta is also 50 degrees, which again proves the point that this is indeed an isosceles triangle. So gamma, you can just use the relation that all three sides of all three angles of a triangle make up 180 degrees. So yeah, in this case, gamma will be 180 minus 50 plus 50, which is 80 degrees. So you found the three angles, and the three sides were already given to you. So solve the triangle using the half angle formula. Now let's see how you can find the greatest angle using the given sides. Now, find the measure of the greatest angle if the sides of a triangle are 16, 20, and 33. Now, before we dive into this, think about this a little intuitively. Let's say this is your side, this is another side, and this is another side. Now, quite visibly, this is the greatest side. Let's say this is the side A, right? So this will be the angle alpha. Let's say this is beta, this is side B, and this is gamma, and this is side C. Now you can see clearly that the angle alpha is the greatest angle over here, right? And so it corresponds to the greatest side as well. It is opposite to the greatest side A. And the angle gamma is over here, and it is the shortest angle, and it corresponds to the shortest side C. It is opposite to the shortest side C. So now look for the greatest side over here. That's 33. So the angle opposite to 33 would be the greatest angle. So you can now use the cosine rule, right? Simply, C is the greatest side. So gamma, which is the angle opposite to C, is the greatest angle. So how do you find gamma? You use the cosine rule. Cosine gamma is equal to a square plus b square, basically the two sides that make up the angle gamma, minus c square, the side that is opposite to the angle gamma, over 2 into, again, the two sides that make up the angle gamma. So you have all of these values given to you, and so now that gives you minus 0.6766. That's cosine of gamma. So gamma is equal to cosine inverse of this value, which gives you 132.58, right? So that is the largest angle of the triangle. Now let's see how you can find the area of a triangle in different cases. So the first case is when two sides and an included angle is given to you, which means that, let's look at this first formula. And let's just look at all three of them actually. It's that's half of BC into sine alpha, which means half of, if a side BC are given to you, then it's necessary that the angle must be alpha, because alpha is the angle that BC make. So for example, if you have this triangle over here, right? Say this is your angle alpha. The side opposite to alpha is the side A, and the other two sides are B and C, right? So this angle that is opposite to this side B is beta, and this side that is opposite to side C is gamma. So if the sides B and C are given to you, it is necessary that the angle that is given to you must be alpha, because those two sides B and C make this angle alpha. Similarly, if you're using this formula, half of AB into sine gamma, that means that if the sides A and B are given to you, A and B, then the angle that must be given to you must be gamma, because that's the angle that A and B make. Similarly, if A and C are given to you, beta must be given. And yeah, all three of these formulas are valid. Just half of two sides being multiplied into the sine of the angle that the two sides make, right? It's the same for all three, and all three are valid for the area of a triangle. Now, let's look at case 2. Case 2 is when you have one side given to you and three angles. All three angles of the triangle are given to you along with one side. then you can use these formulas. Let's say you have this triangle over here, right? Let's say this is angle alpha, let's say this is angle beta, and let's say this is angle gamma. The side opposite to alpha is A, this is B, and this is C. Let's say you're given the side A. Well, you can use this formula, the first one, A squared into sine of the first angle that is not opposite to A, which is beta, into sine the second angle that is not opposite to A, gamma, over 2 sine the angle that is opposite to the side A. Now let's look at the second one, right? Just to make it clearer. This is also equal to, wait a second, not there. This is also equal to B square over 2 sine beta into sine alpha sine gamma, right? So basically you can sum this, you can simplify this by saying, well, if the side B is given to you, divided by 2 sine of the angle opposite to B, so 2 sine beta, and multiply all of that with sine of the other two angles, sine alpha and sine gamma. Same is the case for this one. I'll leave that up to you, but this is the second case for finding the area, right? Now let me just drop this off so we can discuss the third case. The third case states that when 3 sides are given to you, then you can use the Heron's formula. The Heron's formula is just very simple. The area of a triangle is equal to whole under root of s into s minus a, s minus b, and s minus c, where a, b, and c are the 3 sides of the triangle, right? So s over here is equal to a plus b plus c over 2, the 3 sides being added up divided by 2. Once you have all of this, you can easily find the area of the triangle. Now let's see how you can find the area of a triangle in case where you have 2 sides that are given to you and also an angle that is given to you. So if you remember from last time, basically if you have 2 sides given to you and the included angle as well, then you can use this formula, right? So basically it says that, say you have this triangle over here and the sides A, B, and gamma are sides A and B are given to you, also the angle gamma. Now if you remember, we always denote it as the opposite side, right? So the angle alpha will have the opposite side A, the angle beta will have the opposite side B, the angle gamma will have the opposite side C. This is just the notation, the standard notation for this. And to use this sine formula of the area, you need to have 2 sides and the angle those 2 sides make. And luckily enough, in this particular question, we have the sides A, the sides B, right, this side and this side, and we also have the angle between them as 150 degrees. So now you can simply use this formula, half of A into B sine and the sine of the angle that they make. So yeah, just put in those values and you get 600 square units, right? Now remember, let's say that it wasn't gamma that was given to you, let's say beta was given to you, then you could not have used this formula, right? For this formula to work, you need to have 2 sides, but you also need the included angle, the angle that those 2 sides make for this to work. Now let's see how you can find the area of a triangle using 1 given side and 2 given angles. So basically, let's say again, draw the triangle, right? And say this is angle alpha, so this would be side A, this is angle beta, so this would be side B, this is angle gamma, so this would be side C. Okay, standard triangle. Now it says that the side B is given to you, right? And the angle alpha is given to you. So this side B is given to you, this angle alpha is given to you, and this angle gamma is given to you, right? So you need to find the area of this triangle. Now if you remember, in this particular case, since you have the two angles given to you, since it's a triangle, meaning it has three angles, you can simply subtract the sum of the two given angles from 180 to get the third angle, beta, right? So over here, beta turns out to be 98 degrees and 2 minutes, or basically just 98 2 by 60, right? Whatever that is. You can convert it into decimals. So now that you have all three angles, let's see. You can use this particular formula to get the area of the triangle ABC, right? Half of b square into sine of the first angle that is given to you, right? Actually, let's look at it this way. It is b square over sine beta into sine gamma sine alpha. So b square over sine of the opposite angle to b, right? So the opposite angle to this side b is beta. So b square over sine beta, we already found beta over here, into sine gamma, gamma is already given to us, into sine alpha, and alpha is already also given to us, right? So now just insert the values, and it turns out to be 138.29 square units, right? So that is the area of the triangle ABC when you have one side and two angles given to you. Now let's see how you'll find the area of a triangle given three sides, right? So no angle is given to you, only the length of the three sides, right? Now, if you remember, this is the third case of finding the area of a triangle. When you have just three sides given to you, you'll use the Heron's formula, right? So the first thing you have to do is calculate S. S is simply just adding up the three lengths A, B, and C and dividing the sum by 2. So over here, S is equal to 36. Well and good. Now that you have S, you need to find S minus A, S minus B, and S minus C, right? So S minus A, 36 minus 18, which is equal to 18. S minus B turns out to be 12, and S minus C turns out to be 6. Now that you have this, simply just use the Heron's formula, which is S into S minus A into S minus B into S minus C. You have all of these values, plug them in, and this turns out to be 216 square units. A very simple formula, and now we have covered all three cases. Now let's see how you can show that the product of the half angle formula is R. Okay, so it says that we have to prove that this left hand side, R1, is equal to this right hand side, which is 4R into sine alpha by 2, cos beta by 2, cos gamma by 2. We have to prove this. So obviously it's easier going from a larger expression to a smaller expression. So we take the right hand side and let's see how it eventually converts into the left hand expression, which is R1. So 4R into these trigonometric functions. Now you can write down 4R as this. 4 into R is basically the product of the three sides over 4 into the area of the triangle, okay, that these three sides make, into sine alpha by 2 using the half angle formula can be written like this, right? S minus B into S minus C over BC, right? Because you take the two sides, S minus the first side that is not the opposite side of alpha. So basically let me just draw this out again. Okay, let's say this is the angle alpha, so the opposite side would be A, and these are the two sides at B and C. So the two sides that make up the angle alpha are B and C. So you use those two in the sine expression, right? S minus the first side that makes up the angle alpha into S minus the second side that makes up the angle alpha over the product of those two sides into cos beta by 2. Now for cos it's different, the half angle formula, right? It is S into S minus B over AC. Now since this was the side B, so this is the angle beta, right? And this is the side C, so this is the angle gamma, right? Now you can clearly see that cos beta by 2, so the cos of this angle over here is the cos of the half of this angle is equal to S into S minus B. B is the opposite side to the angle beta over AC. A and C are the sides that make up the angle beta, right? So S into S minus the side that is opposite to angle beta over the two sides that make up the angle beta. Similarly, for cos gamma by 2, S into S minus the side that is opposite to angle gamma, the side opposite to angle gamma is C, over the two sides that make up the angle gamma, which are A and B, right? Now that you have all of this, you can cancel out this 4 with this 4, and you're left with this expression, right? You multiply all three of these to get this expression. Now you can cancel out this under root sign with this square, this square, this square, this square, this square, and this square, right? So you get this. Now you can cancel out this ABC with this ABC, and you're eventually left with this expression, right? And you multiply this expression with S minus A into S minus A. Why? Because S minus A is missing from this numerator, right? We need to use the Heron's formula now. So you need S minus A. But since you're multiplying the numerator with S minus A, you need to multiply the denominator with S minus A as well, because the entire value of whatever you're multiplying with has to be equal to 1, right? So the actual expression does not change in value. So now that you have this, once you apply the Heron's formula on this numerator, if you remember, the Heron's formula states that the area of the triangle is equal to under root S into S minus A into S minus B into S minus C, right? So basically this numerator is equal to the area of the triangle whole square, right? So you have this expression. Now obviously you can cancel out one of these with this triangle in the denominator, this area in the denominator, so you have this expression now, and that is equal to R1, the area over S minus one of the sides, that is R1. Now let's see an application of the trigonometric functions and formulas. Now we have to prove that this left hand side is equal to this right hand side, right? This is S square, not S2. Okay, so R1 is equal to the area of the triangle over S minus A, R2 is equal to the area of the triangle over S minus B, and R3 is equal to the area of the triangle over S minus C, right? So you replace these expressions in the left hand side, right? Because we're proving that this left hand side is equal to this right hand side eventually. So once you do this, you get area squared in all of the numerators, right? These two get multiplied, these two get multiplied, and these two get multiplied. So you get area squared in the numerators. Once you take these area squared common, you get this expression in the bracket, right? Now, once you take the LCM in this bracket, you get this expression. Now, you add up these S terms, right, to get 3S, and from that you can subtract C, A, and B, right? A plus B plus C. Now, if you remember that S is equal to A plus B plus C over 2. So A plus B plus C is equal to 2S once you cross multiply. So you get this. 3s minus 2s over the denominator. Now, you need to have an s in the denominator to use the Heron's formula. So what you do now is you multiply both the numerator with s and the denominator with s so that the overall value does not change. And so you get this, right? Because 3s minus 2s is equal to s into s is equal to s squared. And you have this s in the denominator now. Now, if you remember the Heron's formula, it states that the area of a triangle is equal to under root s into s minus a into s minus b, into s minus c, right? Whole under root. Now, you can simply just take the square on both sides, right? So that you can cancel out this under root sign. So area squared is equal to s into s minus a into s minus b into s minus c, which is indeed the denominator over here, right? So you could replace that with the area squared. So you get this. Now you can cancel out this area squared and this area squared. You get the right hand side that we needed, which is s squared.